Right, my dear children. Now, in this chapter, we'll be studying further things related with the current flow. Here, I'm going to give out a solid proof to show that current is flowing from positive to negative terminal. So, to identify the direction of current flow, once again, you will be needing the motor. And also, I told you that we'll be needing a center zero galvanometer or center zero milliammeter or else an ammeter, right? We have to use at least one of the three instruments, like it should be a galvanometer, it can be a galvanometer, center zero galvanometer, or else a center zero ammeter, right? Or else a center zero milliammeter. So you have to use one of these instruments to provide the solid proof. Then after that, we'll be needing dry cells and the switch and some connecting wires also, right? So we'll name the materials given. Center zero ammeter slash galvanometer. Center zero ammeter or galvanometer. Then the motor, dry cells, switch. These are the materials you need, and some connecting wires also to connect the circuit. You know that to connect the circuit, we'll be needing connecting wires, right? So those things are obvious. So I have never mentioned it here. So we'll be needing some connecting wires as well. So these are the main important materials that we need to take when conducting the activity, right? We're needing a center zero ammeter or else a galvanometer, a motor, dry cell, and a switch. So the method, once again, the method is really simple. In the earlier case, we just only used the motor, no. But in this case, we'll be connecting galvanometer or the ammeter between the circuit as per to the given figure. After that, we are going to interchange the two terminals and to see and to observe whether the indicator of the ammeter or the galvanometer is going to change or not. If it is changing, then like in the previous activity, I told you current is always flowing from one certain direction only, right? To positive to negative, right? So that is our final observation. So we'll write down our method then and we'll head on to the lab to conduct the activity. So first of all, we write down the method. So how to conduct this thing? It's really simple. Connect the materials as per to the figure. Connect the materials as per to the figure. So according to the figure, you have to connect the materials. Turn the switch on and observe the rotation direction. Turn on the switch and observe the direction of rotation of the motor and the indicator of center zero ammeter slash galvanometer. Right? So we have to connect according to the given circuit, right? We have to connect the wires according to the given circuit, right? The diagram is given here. So we have to connect this circuit by using the wires and the other materials. And after that, we have to turn on the switch and observe the direction of rotation of the motor plus the indicator of Zender 0 ammeter or the galvanometer, right? Then after that, what you are going to do is, like in the earlier activity, we need to interchange the two terminals of the tricells and observe once again, right? So here we'll write interchange the terminals of the tricells, interchange the terminals of the tricells and again observe interchange the terminals of the tricells and again observe the directions. The direction of rotation in motor and the center zero ammeter galvanometer. Right. So this is the way of doing our experiment, my dear children. So connect the materials according to the given figure. You observed the figure earlier, right? Then turn on the switch and observe the direction of rotation of the motor and the direction and the indicator of the Zender 0 ammeter or the galvanometer. Then after that, you have to interchange the terminals of the tricells and again observe the direction of rotation in motor and the center zero galvanometer, right? So you have to observe the rotation direction in the motor and as well as the indicator of galvanometer or the ammeter, right? So this is the way of doing the experiment. So we'll head on to the lab and we'll conduct the activity and let's see whether we can get the necessary observations. Right, my dear children. Now, in this activity, we're going to observe the certain direction or the direction of current flow or the direction of electric charges in a circuit. So I told you that in the earlier activity, there is a certain direction of traveling electric charges. And I told you that it's always traveling from positive terminal to the negative terminal. Electric charges or electric current is always traveling from positive terminal to negative terminal in any kind of an electric source, right? So now within this activity, I'm going to prove that the charges or the electric current in an electric source is traveling from positive to negative direction. Right. So, to demonstrate that, I have these apparatus in here. I have a center zero ammeter. Actually, in this one, you can observe that the zero is not at the center, but we can observe the direction of current flow quite well, because the reading is at here, and the reading can rotate either to your right hand side or to your left hand side, right? It's not exactly at the center, but still the meter can rotate either to right or left hand sides, right? So according to the direction of current flow, the reading will travel to a certain direction, and we'll observe what will happen to the motor when this reading is going to turn to a certain direction, right? So first of all, I'll set my apparatus. So I have the ammeter, center zero ammeter with me, then the motor, some connecting wires, some dry cells, and a switch. So now I'm going to connect the circuit, and we'll see whether there is a certain direction or else whether the electric charges are being traveling from positive to negative terminal, right? So I'm going to connect my apparatus like this, one end to the motor, negative terminal. So this is my, now in any kind of a ammeter, milliammeter, galvanometer, voltmeter, in any kind of a electricity measuring instrument, you can observe two terminals in here. Actually, there are three. There are three terminals to make or to connect several or different types in different ways, right? So most of the times you will be having two different terminals. One is a black color one and the other one is a red color one. If you take any kind of a milliammeter, ammeter, voltmeter, or those kind of electrical instrument which can be used to measure electricity, there are two distinct, most of the times two distinct terminals, red color one and a black color one. Now here you can observe two red color ones, but both the terminals are same as they are red. So if you check clearly, this red color one is a positive one and the negative one is the black color one. Here you can observe the negative sign as well in the black color terminal. So normally in any kind of a electricity measuring instrument, the black color terminal is the negative terminal and the red color one is the positive terminal. So when you connect this red color terminal, with the positive end of the dry cell or the electric source, the positive end, this one, with the positive end of the dry cell, the instrument or this apparatus or the milliammeter in here should turn to positive direction. Here you can observe two directions. Zero is here. This is the negative direction. See this one, clearly observe the reading. This is the negative direction. This is the positive direction. So when I am connecting this red color positive terminal to the positive terminal of my dry cell, the reading should travel to positive direction. And to observe the direction more conveniently, I have used a motor here. So the motor direction should also be the same as the direction of this reading. Now let's see whether this thing is happening or not. Alright then. So I'm going to connect this positive terminal with the positive direction. So this is the positive terminal. This is the positive terminal of my dry cell. So I'm going to connect the positive with positive here through the switch. This is to the switch. Then okay, so here now the positive terminal goes to the positive terminal of the dry cell, positive to the positive, right? Then the negative terminal. Negative terminal, I'm going to connect with the negative terminal. I'm going to connect with the negative terminal of the center zero ammeter in here, right? And it runs through the motor as well. You can see that it runs through the motor as well. So here I'm going to connect it. Now, if the current is flowing just as same as positive to negative direction, or else positive to negative terminal, if the current is flowing to from positive to negative terminal, okay, then my reading should turn to positive direction, and for the same direction the motor should rotate also. When I'm going to close the switch, my observation would be the reading should move to positive direction, and the motor also should turn to the same, or it will rotate to the same direction as the reading. Now let's see whether we can get this observation or not. Okay, so I'm going to connect it. See, you can see the reading is going to the exact the same way as I told, to the direction of the positive one. Okay, see, I'm going to connect it like this. Then you can see the reading in here. The motor is working. See the direction of the rotation of the motor. See, check the arrowhead. So arrowhead is moving, or the motor is rotating exact the same way as the reading of the ammeter. Once again you can observe, see, the reading is moving to that direction, to my left hand side, and the rotation of the motor also to the same direction. Means that current is flowing from positive to negative direction. That's why the reading travels to positive direction, and also the motor rotates to the same direction as the reading. Now what I'm going to do is, I'm going to interchange the two terminals. Means that I'm going to take this positive terminal and connect it with the negative terminal of the dry cell. Here, this black color end is the negative terminal, right? So I'm going to connect this black color end to this end of the ammeter. This one, this is the red one, means that's the positive one, and I'm going to connect this positive terminal to the negative terminal, and let's see what happens in that case. So if our observations are accurate, like in the earlier case, without connecting this thing, I can say to which direction does the motor is going to rotate, and as well as the reading of the ammeter. So the reading of the ammeter should travel always to the direction of current flow. So the current is flowing from positive direction to, or from positive terminal to negative terminal. So when I'm going to interchange the two terminals, the reading should travel to negative direction. Reading should travel to negative direction, means to my right hand side, this side should travel to this side. And the direction of the rotation of the motor, it also should be to the direction of the reading as well, right? Now let's interchange and see whether we can get these observations or not. So I'm going to interchange the two terminals. So black color one goes to the red color terminal, and the red color one comes back to the black color terminal. Right, so I have interchanged the terminals now. So you can see that red color terminal is connected with the negative terminal, and it runs through here, comes to the switch, and the switch goes to the positive end of the ammeter. See, it runs to the positive end of the ammeter. So negative terminal goes through the switch and comes to the positive terminal. Means that current is now flowing to the opposite direction. So the reading should go to the negative direction, not to the positive direction. If the positive is connected to the positive terminal, negative to the negative terminal, then the reading will travel to the positive direction. If I am going to interchange the two terminals, it would travel to the other direction. Now let's turn on the switch and we'll see whether we can get the observation. So if my activity, or if the current is flowing always from positive to negative direction, then in that case the reading should travel to negative direction like that way, and the motor should also travel to the same direction as the reading. Now let's see whether we can get this observation or not. Observe clearly, children. See, check the reading. Check the reading. See, the reading is now move to the right hand side, and the motor is also rotating. Identify the direction of rotation in the motor. So I'm going to disconnect once again. Now let's observe once more. See, so the motor also rotate into the same direction as the motion of the reading in the ammeter. Means that in this activity, right, see, so it's clear to us, in this activity the current is always flowing from positive terminal to the negative terminal in a electric source. So in dry cells, current is always flowing from positive to negative terminal. Right, my dear children? So you could observe, like in the previous activity, here we provided a solid proof also by using the center zero ammeter or the center zero galvanometer, right? That the electrical charges are going to flow definitely to one certain direction only, and that direction is from positive terminal to negative terminal. The rotation direction of the motor, you could observe that the rotation direction of the motor and the rotation direction of the indicator both have same directions, right? So we'll write it like that way. So our observation is quite simple, my dear children. Indicator, motor rotates to same direction. Rotate to same direction. Both the motor and the indicator rotate to a same direction when you are doing this experiment, right? We did that thing and we could observe the same thing, right? When interchanging the terminals, in that case also, here now we can say that when interchanging the terminals, the direction of the rotation is going to change, but still motor plus the indicator is moving to a same constant direction. Both the direction of both of them are moving to the same direction. So here indicator, motor rotate to same direction. That is in the first step. So in the second step, we can say that when interchanging the terminal, indicator and the motor rotates to opposite direction. When interchanging terminals, indicator, comma, motor rotate to opposite direction. So in brackets, I'll mention opposite to first moving direction. Okay. Opposite to initial direction. Right. Opposite to initial direction. So I'll erase this conclusion part to get some more space. Right. Okay, so opposite to initial direction. Okay. Right. So this is our observation. Indicator, comma, the motor rotate to same direction in the first step. The second step, when interchanging terminals, indicator, comma, motor rotate to opposite direction. So opposite direction means opposite to initial direction, right? Opposite to initial direction. So this is the observation. So we can say that, so conclusion. So our final conclusion is current is flowing from positive terminal to negative terminal. This is our final conclusion. So current is flowing always from positive terminal to negative terminal, right? So this is the final conclusion. So you know that in the early case also we discussed that current has a constant direction of flowing. So that flowing direction is from positive terminal to negative terminal. So we have given out a solid proof for the direction of current flow. Right there. So we'll move on with the other things to discuss about the electric current. So here we'll be discussing in this part how to measure this electric current, my dear children. So you are given measuring electric current. So you know that physical quantities means, what are physical quantities? Physical quantities means anything which you can measure by using a certain unit. Anything that you can measure by using a unit, right? Sometimes there are no units as well, right? For some physical quantities. For a simple example, we can take distance. You know that distance is measured from meters or kilometers. So distance is a physical quantity that can be measured by using the unit kilometers, meters, and so on. Right? There are different other units as well. You know, millimeters, centimeters. Those things are also can be used to measure the distance. Right? Distance means a certain amount of length. Right? So if you take mass, mass is also a type of a quantity which we measure from grams, kilograms. Right? Then if you take time, there are different kinds of units to measure time. Seconds, minutes, hours, days, years, then months, and so on. Right? So physical quantities are the things which we can measure. Right? Anything that we can measure by using a certain unit. So here, physical quantities are measured in various instances. So I have given you some examples as well, like in distance or else in length, when you are measuring mass and so on. For this purpose, various measuring equipments to measure a mass of a certain thing, we use a balance to measure the mass. So that's the measuring equipment. Right? To measure the length of a certain thing, we can use a ruler, meter ruler. We can use a tape, measuring tape. Right? We can use the measuring wheel. Like that way, there are several instruments to measure a length or else a distance. Right? So there are different types of measuring equipments which we can use to measure physical quantities. And various units are used. So units I told you. To measure distance, kilometers, meters, centimeters. To measure mass, kilograms, grams, milligrams, like that way. So these are units. So to measure physical quantities, we use different kinds of instruments and different kinds of equipments as well. Okay. And also different kinds of units as well. Right? So to measure physical quantities, we use different kinds of equipments and different kinds of units. Electric current is also a physical quantity. So electric current is also a physical quantity. Means that we can measure the amount of electric current. Okay. So we can measure the amount of electric current. How much is it? Right? Like that we can measure it. So let us investigate now how we can measure these electrical charges or electrical current. Okay. By now you know how we can measure electrical charges or electrical current. You know what's the instrument that we use. In the earlier case, we took that instrument. That instrument is the center zero ammeter or the center zero milliammeter, right? And also you can use without the indicator at 0, right? You can use just an ammeter or else a milliammeter too, right? Okay, so let's investigate how to measure these electric currents then. Okay, so first of all, you are given with a table under the measuring electric currents. Now, I'm going to introduce to you what are the things contained in this electric current and how we can measure it. What is the instrument that we are going to measure the electric current? And what kind of a symbol that we use to measure, that we use as the symbol for the measuring unit. Okay, so we'll complete this table and get to know about this electric current. So first of all, you are given symbol for the electric current. Symbol for electric current. We use a special symbol to indicate electric current, right? It's not C, right? Current is starting from C, but it's not C. to indicate electric current, especially we use the letter I. Remember, it should be capital. We use capital I as the symbol for electric current. Capital I. Okay. Then international unit, SI unit, standard international unit for electric current. Standard international unit to measure electric current is amperes. Ampere. That's why in an ammeter, at the middle you can observe capital A. Capital A. Because we use ampere, the unit called ampere, to measure electric current. We measure electric current by amperes. Remember, amperes. Next one, symbol of the unit used. Symbol of the unit. So, in an ammeter you could observe it. Capital A is the symbol. Capital A is the symbol. Amperes. Right. So, the second one, subunits are used to measure small currents. We use subunits to measure small currents. Now, if you take a dry cell. So, in a dry cell, my dear children, if you take a small bit of a dry cell, so in a small dry cell, we can't measure electricity or electric current by using amperes, because very less amount of current is getting stored in a dry cell. So therefore, we can't measure it from amperes, right? Very small bit of current is getting stored in a dry cell. Very small amount of current is getting stored in a dry cell. So if you connect a dry cell to an ammeter, the indicator will move slightly. We can't get a very clear value, right? If the indicator is showing like up to 5 or 2-3 amperes, then we can measure. Actually, in a dry cell, the amount of current is like less than 1 amperes. The maximum would be 1 ampere, right? So we mostly use the milliampere, but milliampere should also contains at least up to like 1 amperes. So when we are completing this table, I'll mention what is the relationship between ampere and the milliampere, right? But up to now, you just keep in your mind that we can't measure small currents by using the unit called ampere, right? Okay. So we use 2 different smaller units. It's like this. If you take for an example, we'll imagine that there are 2 cities in 2 different locations of a country. There are 2 cities. Let's imagine that we'll take our Sri Lanka. Then let's take Colombo and Kandy. So if you take Colombo and Kandy, to measure the distance between Colombo and Kandy, we can't use the unit centimeters. We can't use the unit millimeters, because those units are not sensitive to measure those kinds of very large values. We use kilometers to measure, because the distance is much larger, right? The distance is much larger. So imagine to measure the length of this pen. Can we use the kilometers? No, we can't. In this case, we can use the unit centimeters, right? So like that way, to measure larger distances, we use kilometers. In the same way, to measure like larger currents, we can use the unit called amperes. To measure smaller currents, like the length of a pen, distance of a pen. We can use the 2 subunits, smaller units like centimeters. The 2 units are called as milliamperes and microamperes. Microamperes and milliamperes. These are the 2 units. So here, milliamperes. For milliampere, we use this symbol. Simple M, capital A. Simple M, capital A. Milliamperes, the symbol. Then the next one, microampere. Microampere. For microampere, we use this symbol. See, this symbol. This symbol which is located at here, it's not U, it's like this. This is called as mu, M-E-U, mu. Mu, a special kind of a symbol. It's not in our alphabet, English alphabet. Okay, a special kind of a symbol, mu. We use this mu thing to indicate microamperes. Okay, mu, microamperes. So, like U, but it has a like some kind of a curve at the starting or at the beginning of the symbol. See this one, mu. So, mu amperes, microamperes. Right. So, here you are given with the relationship. Check the relationship. If you take 1 ampere, my dear children, 1 ampere is exactly getting equal to 1000 milliamperes. 1 ampere is exactly getting equal to 1000 milliamperes. Okay. 1 ampere is equal to 1000 milliamperes. Then, if you take the next one, see, 1 milliampere is getting equal to 1000 of microamperes. So, this microampere unit is very smaller, much smaller, right? I'll mention the relationship between amperes and microamperes. Okay. So, 1 ampere in microamperes should be thousands of thousands. Means how much? 1000 times 1000. Altogether, then count how many zeros are there? 1, 2, 3, 4, 5, 6. So, there are 6 zeros. So, 1 ampere is equal to 1 million. It's 1 million. 1 million of microamperes. Right? 1 million of microamperes. So, these are the smaller units that we can use to measure electric currents. If you use microamperes, right? If you use microamperes are very smaller currents, right? We can measure microamperes even in our bodies also. Some amount of microamperes of current is being transferred within our body as well, as emotions, as impulses, right? So, we'll be learning those things in our next grades. So, these are the relationship between the 2 smaller quantities which are referred as microampere and the milliampere. Okay. So, what are the relationships? 1000 of milliamperes is equal to 1 ampere and thousands of microamperes are equal to 1 milliampere. Right? Thousands of milliampere is equal to 1 ampere and 1000 of a microampere is equal to 1 milliampere. Means that finally we can say 1 ampere is equal to exactly 1 million of microamperes. Right. Okay then. So I'll erase these things. Right. I'll erase these things. Actually, you won't be needing that third one, but I have mentioned it. After completing the table, I'll mention the third relationship as well. Okay. Right. So we'll erase these things. Right. So the third one is, what is that? 1 ampere is equal to 1 million. 1 million microamperes. This is the third relationship. 1 ampere is equal to 1 million microamperes. Right. So these are the units that we can use to measure electric current. Then the next one, the equipment used to measure current. Equipment which can be used to measure current. You know the equipment that we use to measure current. It is called as the ammeter. So there are different types of ammeters. To measure smaller currents, we can use the milliammeter. To identify the direction of current, we can use the center zero ammeter or center zero millimeter. To measure very smaller currents, we can use the microammeter as well. So no matter whatever the unit, we use the instrument called ammeter to measure the electric current. Right? We use the instrument called ammeter to measure the electric current. There are different types of ammeters. According to the purpose that we need, we can use different types of ammeters. So, however, we use the equipment called ammeter to measure the current. So, children, equipment used to measure current is called ammeter. Ammeter. Then the symbol of the equipment or the instrument. Here actually we are discussing about circuit symbol. Right? The circuit symbol. So circuit symbol of an ammeter is like this. Ammeter has two different terminals. Right? Ammeter has two different terminals. Right? To make our work easy, to make our connections more easy and convenient, sometimes there are ammeters with 3A. Okay? There are 3 terminals. In the when we are conducting several activities, after this part of the lesson, I'll explain what is the purpose of having 3 terminals. Okay? So sometimes there are 3 terminals, but most of the times, if you take a certain ammeter, right? If you take a certain ammeter, it has only 2 different distinct terminals, right? Those 2 distinct terminals are positive terminal and the negative terminal. So most of the times, these terminals have different colors. Always, all the time, the negative terminal is indicated by using black color. Negative terminal is more often being indicated by using black color, the negative terminal. By using the red color, positive terminal is being introduced. Right? These are the colors that we use in more often. Right? Commercially, when ammeters or milliammeters are getting produced commercially, the positive terminal is marked from the red color, whereas the negative terminal is being marked with black color. Right? So these are the international standard colors in representing positive and negative terminals. Right? So this is the symbol then like a bulb, a circle, then after that capital A should be introduced within the circle. Then remember, my dear children, you have to mention the two terminals in the ammeter, right? So this is the plus terminal, and I'll mark this one as the negative terminal. So this is the international standard symbol to indicate an ammeter. Okay, ammeter is being represented like this, right? So milliammeter or microammeter can be used to measure small electric currents. In the earlier case also, I told you that we use this milliammeter, microammeter or center zero ammeters in different purposes according to the occasion that we are going to use, right? According to the occasion that we are going to use, right? There are some certain situations we need to use different types of ammeters. Now in the earlier activity, when we are finding out the direction of the electric current, we use the center zero ammeter. So like that way, there are different types of ammeters, right? So different types of ammeters are being used in different purposes. To measure smaller currents, we use microammeter or the milliammeter. So this is all about with the electric current then. Once again, we will memorize. Symbol for the electric current is capital I. International standard unit for electric current is the amperes. And we use capital A as the symbol for amperes. To measure smaller currents, we use two subunits as milliampere and microampere. 1 milliampere, right? 1 milliampere is equal to 1,000th of an ampere. To make the relationship somewhat convenient, we have used 1000 milliamperes are equal to 1 ampere. 1000 milliamperes are equal to 1 ampere. Then if you take the microampere thing, 1000 of microamperes are equal to 1 milliampere. Thousands of microamperes are equal to 1 milliampere. Means that if you take the relationship between amperes and microamperes, 1 million microamperes are equal to 1 ampere. 1 million microamperes are 1 ampere. So the equipment which can be used to measure electric current is called as the ammeter. It is called as the ammeter, right? Ammeter. Then symbol of the instrument or the circuit symbol of the instrument, right, is this. There are two distinct terminals, positive and negative. Circle A, then the two terminals. So this is the circuit symbol for the ammeter. And according to the purposes that we are going to use, there are different types of ammeters like milliammeter, microammeter, and center zero ammeters, right? So to measure small currents, we use the milliammeter and microammeter. To identify directions, we use the center zero ammeters, right? So this is all about with the electric current then, right? So I hope that you got a sound knowledge about electric current. Okay, my dear children then. So there are two terminals. So I told you that there are two terminals, positive and negative, in ammeter and milliammeter. So whatever the ammeter type, there are two different terminals. Okay, there are two different terminals. So you are given with 3 points, right? You are given with 3 points. Let's see what are these special points that we need to remember when you are using an ammeter or milliammeter, right? First thing, we wrote that thing earlier also. So I'll use the red color. There are two terminals. You know that there are two terminals in an ammeter. First terminal is the red color terminal, the positive terminal. So positive red color, and the other terminal negative black color. So the positive terminal is normally in red color and the negative terminal is normally in black color, right? Positive and negative terminals. Okay, second most important one. When you are connecting an ammeter to a circuit, it should be connected in a series connection, right? Ammeter should be connected in a series connection, my dear children. Right then. Second one, ammeter should be connected series. Ammeter should be connected in a series connection. So for now, just for now, don't think much about this series connection thing. Series connection, don't think much about that thing. I'll explain what do you mean by a series connection. Okay, right? So after writing down these special points, I'll explain what do you mean by a series connection. So ammeter should be connected in a series connection. Always ammeter should be connected in a series connection. And the other important fact, when connecting ammeter, the positive terminal should connect with the positive terminal of the electric source. Negative terminal of the ammeter should connect with the negative terminal of the electric source. Unless it is a center zero ammeter. In a center zero ammeter, the indicator is moving to either sides, no? So we can measure whatever the side the indicator is going to move, we can measure the amount of electricity. But if just an ammeter, a usual ammeter is used, the indicator will rotate only to a one certain direction. Normally it is clockwise. So in order to move the indicator, ammeter should be connected properly to the circuit. So that proper connection method is positive terminal of the ammeter with the positive terminal of the electric source, negative terminal of the ammeter with the negative terminal of the electric source. So that's the third most important factor. What is that? Third most important one. Right? So the third step is in connecting ammeters, positive terminal should connect with positive terminal of the circuit So remember, positive terminal with the positive terminal of the circuit. So you know that we use black color to indicate negative terminal. So I'll use the black color. Then the next step, second step, negative terminal should connect with negative terminal of the circuit. Right, my dear children. So these are the most important factors that we take into consider when connecting an ammeter. Once again, there are two terminals, positive is in red color, negative is in black color. Ammeter should be connected in a series connection. Ammeter should be connected in a series connection. Number 3, in connecting ammeters, positive terminal should connect with positive terminal of the circuit. So, to measure electric current properly, we need to connect the positive terminal with positive terminal. Negative terminal should connect with negative terminal of the circuit. So, negative terminal of the ammeter should connect with the negative terminal of the circuit. Right? So, I hope that you took sound knowledge about connecting ammeters properly and how to measure it. Okay? So, I told you, don't think about this series connection thing. When we are discussing further activities, now we have to discuss some activities on how to get some measurements related to electric current. So, in that case, I'll explain what do you mean by a series connection. Okay? So, up to now, my dear children, just remember these 3 most important points in connecting or in using an ammeter. Red is positive, black is negative. Ammeter should be connected in a series connection. In connecting ammeters, positive terminal should be connected with the positive terminal and the negative should be connected with the negative terminal. Right, my dear children, now in the next chapter, we'll discuss how to connect these ammeters and how to get relevant measurements. Okay? Right. Now, let's see what are the other things contained in our lesson. So, these are 2 types of ammeters you can observe. So, I told you there are some certain ammeters. If you take one certain ammeter, see here the indicator in this end where it is at far left corner. So when you are going to connect these 2 terminals to the electric source or to the electric equipment, indicator will move clockwise. See, it will show a clockwise rotation. It's not going to move to this direction, no. Will show a clockwise direction like this. So this is not a center zero ammeter. It is just an ammeter which we use to measure the electric currents. So in the earlier case also I told you this thing, ammeter, right? Ammeter, right? We use this ammeter thing, ammeter which used to it is used to measure large amount of electric currents. So here this is the ammeter. So ammeter which is used to measure large amount of electric current is given in this figure, right? So this is called as the ammeter. So normally here this is 0 and here like if it is like a larger ammeter, I mean like if we can measure very large amount of current. So normally here it's being printed like 2, 4, 6, 8, 10 and so on, right? There are some smaller ammeter as well. So smaller ammeters as well, like up to maximum it is showing like up to 5 amperes. So the scale is like starting from 0, here 0.5, then here 1, here 1.5, then here 2, then 2.5 and 3. Like that way, there are some smaller ammeters as well. Okay, according to the purpose, there are several ammeters. According to the purpose, we use different kinds of ammeters with different scales, right? Okay, so ammeter is the instrument, however, which we use to measure large amounts of current, like 2 or 3 amperes, up to 1, 2, 3 amperes, 1, 2, 3, 4, 5, like they can be more, even more, right? However, if the current is in ampere amount of value, we use this ammeter to measure those kinds of values. Okay, so the next one, milliammeter. Actually, now if you take a milliammeter, most of the milliammeters are center zero, like this. Means that milliammeters are being used to identify the direction plus to measure the amount of electricity as well. So in an electric source, if we can't identify positive and negative terminals directly, we can use the center zero ammeter. How come? It's because that in the earlier case we studied, current flow is always happening from positive terminal to negative terminal, my dear children. So according to the direction of indicator, right, according to the direction of motion in the indicator in this case, right, we can find out the direction of motion, the direction of current flow. If you know the direction of current flow, then we can identify the positive and negative terminals. For a simple example, I'll use a simple figure like this. So this is my ammeter. Okay, this is my ammeter then. And I'll mark the two terminals, positive and negative, by using red and black color. So this is the positive terminal. I'll use the red color. So this is the positive terminal, red color, right? And this is my negative terminal, black color. So let's connect a cell like this. There is a cell, and within this cell there are two terminals like this, and let's imagine that the outer covering of the cell has been completely removed. We don't know, we can't identify positive and negative terminals because positive and negative terminals are not being printed, right? It's not being printed. So now when you connect this, so I'll use the red color. See, red color with this thing, okay, and black color in other way around. Right, now you know that the indicator of if this is the indicator will move to a certain direction. So we'll imagine that indicator is getting moved to this kind of a direction. Starting from here, this is 0. It is being moved to this kind of a direction then. Right? Means that current, I'll use a different color. The current which is coming from the electric source is coming from here, here, and going through here, and comes to the negative terminal and travel back to the source, like this way. So in that case, the indicator will turn to clockwise direction. So if the indicator is turning to clockwise direction, we can say that this terminal is positive and this is the negative. Why is that? Because current flows always from positive to negative. According to the direction of indicator, it's showing this direction, means that current has flowed from this positive or red color terminal towards the negative black color terminal. So current should definitely come from this red color terminal here. That's why it is going to the other side by turning the indicator clockwise. So we can identify this terminal as the positive and this terminal as the negative in this unknown electric source. So this is the use of this milliammeter thing, center zero millimeter. Actually we use to measure smaller currents plus to identify the terminals as well. Right, so I'll erase this thing. So here you are given milliammeter is used to measure small amount of current in a circuit. To measure a very small amount of current in a circuit, we use the instrument called milliammeter. So milliammeter, small amount of current. We use milliammeter to measure small amount of current. So this is, my dear children, about the ammeters and milliammeters. Okay, so I hope you got a sound knowledge about electric current and how to measure the electric current and what is the instrument used to measure electric current, what are the units which can be used to measure electric currents, and those kind of stuff. So in the next chapter, we'll discuss further things related with the measurement of electric currents, right? And how to get accurate measurements. What do you mean by that series connection and so on, right? So I'll meet you on the next chapter to discuss about further things related with the electric current.